is Chapter 3 review worksheet for calculus. Short chapters, so a couple of things we learned. So this front page, we're just supposed to solve each inequality and graph the solution. And so here we would add 11 to both sides. Get 5x is less than 20, divide by 5, x is less than 4. So that would be an open circle on 4 and headed to the right. And x is less than 4 is the answer there. Here, you could distribute that 1/3 and then, but you could also just multiply both sides by 3. And that's what I would do. I would multiply this by 3 and I would multiply this by 3. So for this side, those 3's are going to cancel, and I'll just have x minus 1 is less than or equal to 2x plus 5, because those 3's will cancel. And then we'll bring the 5 over here, -6, and bring the x over here, get x. And then you know how I am, I prefer x is greater than or equal to -6. So 1, 2, 3, 4, 5, -6 would be here. And that'll be a closed circle headed this way. And x is greater than or equal to -6 on the answer one. This next absolute value problem we can actually do graphically. So my starting point is -5. So 1, 2, 3, 4, 5. There's -5. I'll put a little x there. Then I'm going to go 4 in each direction. So I'm going to go 1, 2, 3, 4. Put an open circle. I'm going to go 1, 2, 3, 4, and put an open circle. And then I want the distance between -5 and those numbers to be less than 4. And so that would be in between here. And then, let's see, that's at -1, 6, 7, 8. That's at -9. So we write the inequality. -9 is less than x is less than -1. That would be the solution to that. On this next one, I can't solve that graphically because of the coefficient on x. And so I apply the definition of absolute value to the inequality, and the 2x minus 3 goes in the middle, and then less than or equal to, less than or equal to, and on this side I put -1, and on this side I put +1. And that's just applying the definition. I like to just solve it where it is, add 3 to all 3 parts, and I get 2 is less than or equal to 2x is less than or equal to 4. And I'm going to divide all parts by 2, which will give me 1 is less than or equal to x is less than or equal to 2. And that's my inequality answer, less than or equal to x, less than or equal to 2. And then I need to graph that. So I'm going to put a closed circle at 1 and a closed circle at 2. It's a fairly short solution. And less than is in between them. Okay. The next two are polynomial inequalities, and I'm going to jump to number 6, and then we'll come back to number 5, because number 6 is already all factored for me. I just need to look at those factors. So I have x minus 1, x minus 5, x minus 2, and x minus 3, and that one's squared. Okay, so x minus 1 is going to be 1 or 0 at +1, and to the left of that it will be positive. I'm sorry, crazy. To the left of that will be negative, and to the right will be positive. And negative 5 would be 0 at 5. So 1, 2, 3, 4, 5. That's right here. So I put my line going down, and it's going to be negative to the left of that. And then to the right, it will be positive. Minus 2, x minus 2 will give me a line, give me a 0 at 2. And again, negative to the left, and then positive to the right. Then x minus 3, yeah, these are all bunched together. I should have made one of them plus, so that we'd be on the other side of 0. X minus 3 would be right here. Okay, draw my line, and it is being squared, and so it's positive everywhere. And so on. Okay, and I want my result to be less than or equal to 0, which means I want my result to be negative. And if I look over here, a negative times a negative times a negative times a positive is a negative. Okay, so that region is negative. And then in between 1 and 2, I have positive, negative, negative, positive. That's going to be positive. And in between 2 and 3, I have positive, negative, positive, positive. That's going to be negative. In between 3 and 5, I have positive, negative, positive, positive. That's going to be negative. Okay. And then positive, 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 positive will be positive. Okay. So the tricky part here is what's going on between 1 and 5, because those are both negative. But notice that 3 here is in the denominator of the fraction. And that means that x cannot equal 3. Okay, but x can be 0. But the only places it can be 0 are at 1 and 5. At 3, we have to put an open circle. And at 2, we put an open circle, even though it's not, well, it is involved. Okay, so anyway, our answer is this. This is going to go this way, right? Because that's where that product is negative. And then this is going to be in between here and in between here. And so we express our answer. This is x is less than or equal to 1. Or, and we can do this two ways. We can say 2 is less than x is less than 3. Or 3 is less than x is less than or equal to 5. That would be one way to do it. The other way to do it would just be to say, you know, it's between 2 and 5, but x cannot equal 3. So you could say x is less than or equal to 1, or x is, or sorry, 2 is less than x is less than or equal to 5. X cannot equal 3. That would be another way to do that one. Okay. Number 5, I'm going to actually do that on another piece of paper. I don't think I left myself enough room there. Minus 5x plus 2 less than 0. Okay. So we need to factor this before we can figure out how we're going to graph and what the solution will be. So I'm going to do some synthetic division. Negative 5, 2, 3, 2, 1, 0. And I need the remainder to be 0, right? I'm actually going to try 2. So you bring the 2 down, you multiply, you add. That's 6, that's 1, that's positive 2. Okay, so that's not going to work. Maybe negative 2. So bring the 2 down. I'm sorry, I did that wrong, didn't I? Bring the 2 down, I multiply, I get 4. And 1 plus 4 is 5, and that's 10. And that would be 5, and that would be 2 doesn't work. Okay, even though I did it wrong, it still doesn't work. So I'm going to try -2. So that would be -4. That would be -3. That would be 6. That would be +1, and that would be -2, and that would be 0. Okay. So to factor this, I'm going to have x plus 2, and then I go to my factor puzzle for that quadratic. This is going to be 2x squared. This is going to be 1. This is going to be -3x. So obviously 2x and x, 1 and 1, 2x and x, and they both need to be negative for this to work. All right. So I'm going to have x plus 2, and I'm going to have 2x minus 1, and then I'm going to have x minus 1 is less than 0. And so I go to my number line. And I check x plus 2. So that's 0 at -2. All right. It's going to be negative to the left and positive to the right. And 2x minus 1 is going to be 0 at 1/2. And so negative to this side, positive to this side. And x minus 1 is going to be positive at 1. Negative, 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 and then positive. And this one was positive in here. So overall, what I have, negative times a negative times a negative will be negative. This will be positive. Looks like between 1/2 and 1 is going to be negative, and then to the right of that's going to be positive. And to write the inequality, I would write this is at -2, so x is less than -2, strictly less than because it doesn't say less than or equal to 0, so strictly less than, and or 1/2 is less than x is less than 1, and again, no or equal to is because it's strictly less than, it's not equal to 0. Okay. Then I printed these out at home, and the graph paper for some reason didn't want to print, so we'll wing it. It'll all work out. Put a little scale on here for the x and y axes. So we start at the y-intercept, which is -2, and I'm going to rise 1, 2, 3, and run 1. And that is going to be a solid line. And if I plug in the origin, I get 0 is less than or equal to -2. That's not true. So therefore, I'm going to shade it down here. So we are below the line. Okay. Then we have this little parabola for the next one. The x value of the vertex, we start there, is the opposite of b over 2a. And then I plug that in, I get 1 minus 2 plus 3, which is 2. So my vertex is at 1, 2, and it opens up. So right there. And if I plug in 0, I get 3. I can use the axis of symmetry to get this point. If I want to plug in 3, I don't think it's going to fit on my graph, but we can try. That would be 9 minus 6 is 3, plus 3 is 6. I guess it will. I'll fit right there. So 3, 6. And then that would be -1, 6. And oops, that should be dotted because it's strictly so strictly less than. And then if I plug in the origin, I get 0 is less than 3. And that is definitely true. 0 is less than 3. So this is going to get shaded to the outside. Not my favorite. I like them when they're shaded. The parabolas are shaded inside, but we'll get along with it. It's all right. Okay. Nice and pretty. I also don't like it when I make the strictly less than and not, because you just start in drawing that parabola and then you realize, oh darn, it's got to be a dotted line. Bueno. Anyway, now we're going to graph a parabola and a line and see where those graphs overlap. So the line intercept is at 0 and the slope is negative 2/3. So I'm going to go down 2 and run 3. And that is going to be a solid line. And since it goes through the origin, I can't use the origin to determine where to shade. So I'm going to pick this point 4, 4. Okay, and that'll tell me whether or not I should shade up here. So if I plug in, that's silly. I'm going to plug in 3, 3 because you'll see why. So 3 is less than or equal to negative 2/3 times 3. 3 is less than or equal to negative 2. It is not. So that means when I get around to shading this, it's going to get shaded this way. Okay, and I'm not going to shade it yet because I need to see where that's going to overlap with that parabola. The parabola, the vertex is going to be at 0, negative 3 because there's no linear term. So when I go to find the opposite of b over 2a, it's going to be negative 0, which is really neither negative or positive. It's going to be 0 over 2, which is 0. And then if I plug 0 back in, I get negative 3. So for that parabola, the vertex is at 0, negative 3, and that parabola opens up. So I'm going to plug in 1, and if I plug in 1, I get negative 2. And if I plug in negative 1, I would also get negative 2 because of the axis of symmetry. And then if I plug in 2, I'm going to get 1. And then using the axis of symmetry, I could do that over there. And then that's going to be a solid parabola because it's greater than or equal to. Then if I plug in the origin, I get 0 is greater than or equal to negative 3. And that is true. So the line is shaded below. The parabola is shaded inside. So the shadings overlap right here. Okay, that's where the shadings would overlap between the parabola and the line. So not a bad set of problems, kind of fun. So we'll have that test and all is well.